Hello, this is mathjazz from Almost Cool, and this is episode 3 of Variant Limits. So, without any further ado, let us play the game.
No configuration that will allow the wheels to line.
Good.
Oh, that was kind of strange. Okay, so we were going down the stairs to see what was out here.
In devising the tower, Kalos was somehow able to reconnect with some fragment of the lost knowledge of the First Era. It is still a matter of some speculation what drove him to develop this plan to use the power of the crystals to build upwards. A common speculation is that it was fear of the demon of the dark, the unseen marauder of the caverns, which drove him. Yet the tower was far more than a mere ladder. The power of the Lapis soul had been tapped again, unleashing the energy stored within the planet once more.
That was a fun little piece of prose there. Having the spectacles sitting on the table, and then using the word speculate and what was the other one? But basically variants of the word spectacles. That was nice. I like that. Wish I could listen to them again. You can see. Can't listen to anything a second time. Okay, so let's go down here.
We may have to make use of division operators here.
Division operators permit control of the angle of the projected beam by taking the quotient of the two crystals' output.
Yes, that was the point I was making, thank you very much.
They have a lot of this, one of the voices says something, and then the other one contradicts them or gets upset with them. Probably didn't need quite as much of that. Okay, so we want F over G to be something. To be 2? No. To be a half. We want to hit a half. And so right now we have 2 and -1. So our output is -2. But, okay, and F is on the top, G is on the bottom. So we need... This will work. See, F is 2 here, and G is 4 there. And so we just take the limit from the right, and we get the fraction we need. So, I did speculate, I don't know if I said this on camera or not, an episode or 2 ago. I was wondering if we'd actually have any computations in this game, and it looks like we're starting to do that. We're starting to have to actually do some number crunching, which is important. If you're going to learn calculus, you know, you have to actually, you can talk about concepts all you'd like, but you really need to get down and do some crunchy computations just a little bit, just to really get it to sink in what's going on. So I'm gonna go up here.
If the distributary can't get us data access, where else might we have a working feed?
The master node for the city's power division is located at the Archivarium. Logically, that would provide an alternative point of access.
The distributary is closer, though. We should try there first.
Okay, so we want F plus G to equal -4. I guess that would have to be here. And we want F to be 0, G to be 4, so if we take the limit from the right-hand side in each case, that'll give us 4. And then there are these wheels in the way. Fascinating. Maybe this controls a wheel? Ah, yes. Okay. So, we want... Well, we want this... This is at 2 pi. We want it probably at... 2 pi is once around the entire circle. we want it to do a quarter of a turn to the left. So what we want is to be at like half of pi, or at 2.5 pi. So what we want is to be here is half of pi, and here's half of pi, and here's half of pi. And then we want, I guess we want G to be in the same spot, so let's see. We picked that spot. Oh, I guess half of, why are they having it rotate clockwise? Traditionally in mathematics, angles are measured counterclockwise. So I guess we want we want 3 pi over 2. Yeah, see, so that's the angle we want to get the laser to focus properly. I wonder, does it let us? I guess it has to be exactly 3 pi over 2, even though we should be able to wobble the disk a little bit so that it's not at pi over 2, but the laser still goes through this giant hole here. Okay, so we want 3 pi over 2, so 1.5 pi. We want this one to be the same, so let's see. Ah, but G doesn't ever get all the way up to 3 halves pi. So what do we do? This is the other part where it equals 3 halves pi. And here's another one. Those are pointing the wrong way. See it. Oh, wait, there's a blue orb there. Is that, am I supposed to power that blue orb between the two discs? No. Oh, that blue orb is on top of this blue teleport pad thing. So it looks like we can't aim at the -4. Let's try aiming at the 2 target here. So if I want f plus g to equal 2, and when I say f plus g, I mean either as functions or the limits of these functions adding up to 2. I can do that here. Notice if I take the limit from the right-hand side, the limit of g is 0, the limit of f is 2, so that adds up to 2, and that aims right at this this node here. And then I can look at my other puzzle to try and rotate these spheres. Instead of having f at 1.5 pi, I want f at 0.5 pi, so let's try, here's 0.5 pi. And that's what we need. And then we use the pad to teleport over there. I thought there was something dangerous about using this teleport as opposed to like the teleport at the end of a level. I guess that we're just gonna keep doing risky things. Ooh, ladder. Can't walk up the ladder. Okay, so this is another thing. Although we have never before had a reason to travel beyond our world, I see now the possibility of saving our people. While propulsion for personal transport is hardly unfamiliar, it never occurred to me that something on the scale of a city could extend those principles into an interstellar context. Yet it can and must be so. These star arcs, I propose, are the only possibility that any of the Mantha might escape the new cataclysm. But it will not be possible to house all our people in the number we could build with the available resources. Difficult decisions must be made. That is a common story element.
The solar flares are becoming more frequent. This cannot be good.
Periodicity of coronal mass ejection events irregular, but mean interval decreasing.
That's exactly what I just said.
Oh. Now, what is it pointing at? Okay, so we need f divided by g to be a half. So we're trying to hit this here. Or are we trying to hit this negative half? Okay, we are here. Let's go down here first. So we want to hit a half. So how do we get a half? Well, we can take... See, the interesting thing is you can't take the function's value for f and the limit's value for g. I don't know which I want right now. Let's see. If I take the value here, this is a 3, and that's a 1/2. So I'm just gonna go there, and that'll hit the target. Great. Okay. We'll go there. Okay, so form a path with platforms. So I can sink that one into the ground, but where's my other platform? It says platforms. Oh. This is the G. Oh, and this is the F. So there we go. Okay. So I guess I just need these to both be above water. I guess I can either have them level with each other, or I can have one level with the third. I'll probably want this. Okay. So let's go down here to see if there's anything else. I like how the teleportation looks. This game. Oh. Does not like how I set that up. So if I want to hit a negative half, then let's see. This is what I want. And we want to have this is divide. Oh, we need to have the limit from the left. So again, the limit from the left here is 2, the limit from the left here is -1, and that gives the -1/2 that I was looking for. Oh, do I have to complete the whole platform? Okay, so we want these to equal 2. That happens. This equals 2 here, here, and this is where we're gonna go, right there. Notice that if I take the limit from the right, I get a value of 2, and that makes the platform level all the way across. You see, I didn't even see that 4th platform there. come now. Like, that is a completely legitimate pathway. Does it want it totally level or something? Let's see. This is how I get to the other one. Okay, so right now I have 2.5, but it wants 2. Maybe it wants 2.5 on the other one. Let's see. I could sync them. Ah, here we go. 2 and 2. Now it's level. So I should totally be able to walk on a non-level platform. Huh. Doesn't like that. Okay, so I think we had it here for 2.5. Here for 3. Let's try 3. And okay. So, where are they both equal to 3? Looks like there's a 3, and there's a ah. Nope. There's a 3. 3. Wait. Yes. This is what I want. I think that solution I made at 2 should have been fine. But
Well done, Equa.
I guess this character can't jump. She can only turn on and off a line in the ground. Okay, let's take a look. Okay, I'm either trying to hit a half, or I think that's the only possibility. Okay, so F over G, and we need it to be a half. Let's do 4 over 2. There we go. We want the limit from the right. There we go. Oh yeah.
The Star Arc project of the Polar Escarpment is progressing at a rate beyond my expectation, but the people of Vetrana have already surmised what I sought to conceal from them. We cannot take everyone. Panic breeds unrest, both here and in the Citadel. I stand by my decision. If there is a future for us, we must save the best and the brightest. It is the only logical choice.
I mean, the Mantha survived by digging caves in the ground, so why not You know, send some people off into the stars to remember technology, and send the rest of the people underground to live. And then have them come back. I mean, I'm just gonna take at face value that they have these limitations and they're not lying about them or something. Because it's completely, you know, it's massively expensive to launch anything into space. So, launching every person on a planet, of course, is going to be prohibitively expensive for most civilizations. There we go. So we're trying to hit 18 F times G. So, let's see. I mean, I need to have... This region of the graph here, F is at 5. And this region here, G is less than 2. So, 5 times 2 is only 10. It doesn't make it anywhere near 18. Then we have here to here. It's way too low. We get out here, near 4 times 4 is 16. That's still too low. This is 4.5 times 4. That's where we need to be. There's no other way around, is there? I wonder what this little blue sphere is there. Like, that should be something to interact with. But... Game is starting to freeze up strangely.
With Father gone, it becomes clear that our people are not as united as I once believed.
Huh. That didn't go into the cut screen thing. Okay, 2.5 times... We want to hit 4. Okay. Well, let's do this, and let's do the limit from the right. There you go.
Crystal simply cannot channel this much energy.
Photomimetic harvesting is autonomic, not elective.
No. Excess solar collection wouldn't account for magnetic storms of this magnitude. There has to be something else behind it.
Oh, here it is. Okay. Let's see. We want to hit a target of 9. So, let's see. So here's 4.5 and 2. And the limit from the left side will give that to us. There you go. Used to be able to interact with these things by pressing E, but it looks like now I have to click on them. Okay.
I think this passageway leads to the distributary, but the security system is probably more robust than most we have encountered.
Confirmed. Gate security designed by Castor and exceeding nominal standards.
This could be a tough nut to crack.
So, by the way, it's terrible security to have a math problem like this as your security. But we need to hit a target of 2.5. I think the best way to do that is here. The limit from the right on each side. 1 divided by 2. F over G. 1 over 2 is a half. I mean, that's what I'm supposed to do, right? I'm not sure if that did anything. Oh. Okay, so this thing here is now shooting up there instead of wherever it was. And I guess now I have to do 5. F times G to equal 5, so let's pick... That's 2.5, that's 0. Ah, here we go. 2.5 times 2, we take the limit from the right. Because this limit is -2. This limit is -2.5. The negatives cancel, leaving with +5. And wish I could see what I was doing. Oh, I probably have to go around to the back side of this. There we go. Target of 2, F plus G. Let's take, how about 1.5 plus 1/2?
Fantastic! You did it!
Oh! That's great. This is one of those end pads.
We've made it to the distributary, at last. From here, we can track the status of the entire phenomenic network. But this isn't right. All the power is pulling to the polar escarpments, and there are major induction events throughout the magnetosphere.
Confirmed. Do you wish to extrapolate a cause?
Of course! Show me!
Analysis reveals a tether between the planet's magnetosphere and that of the nearest sun.
Someone has channeled the power to the planetary poles. It's creating incredible magnetic force.
If this situation is not resolved, the most plausible outcome is the destruction of all structures upon the surface.
We have to find a way to redistribute that power flow before it's too late. This happened before. Why can't I remember?
Okay, so this is where we'll wrap up for now, and we will come back in the next episode. So, see you in a couple of days for Variant Limits 4. Bye!